Yeah, hello everyone. My name is Venkata Swamy, Associate Professor in Mlritm, Department of Chemistry. Yeah, as a part of engineering chemistry subject, we have discussed polymerization topic in the last class. In types of polymerization, there will be three types of polymerizations. One is the addition polymerization, second one is the condensation polymerization, and the third one co-polymerization. Among these three types of polymerization, the first type of polymerization we have discussed in the last class, that is addition polymerization and its mechanism with suitable examples. And coming to the second type of polymerization, that is condensation polymerization. So what is meant by condensation polymerization? In the last class we have discussed, even though, so I am repeating what is the concept of here condensation. So polymerization, as you know, the polymerization is nothing but it is simple, it is a chemical reaction in which the monomers are same or different. And if you use the monomers are same, or we can use the monomers are different. And during the process of formation of a polymer, there will be a chance the elimination of a smaller molecules, or there will be a chance in during reaction without the elimination of a smaller molecules. And finally, it will lead to the formation of a micromolecule. What is it? Micromolecule, or we can call as giant molecule, or a higher molecular weight of compound is called as polymer. And this phenomena is called as polymerization. So finally, the polymerization can be defined as the polymerization is a chemical reaction in which the monomers are same or different. During the process of forming a polymer, with the elimination of smaller molecules will takes place, or without the elimination of smaller molecules will be takes place. And finally, it will lead to the formation of a macromolecule or a giant molecule, or higher molecular weight of compound is said to be polymer, and this phenomena is called as polymerization. But here the thing is different, the polymerization type is different, that we can call as condensation. So what is meant by condensation? So during the process of a formation of a polymer, there will be where eliminating of a smaller molecules takes place. So nothing but condensation polymerization can be defined as a giant molecule is formed, a higher molecular weight of substance is formed by the elimination of a smaller molecules like H2O, like carbon dioxide, like HCl, like NaCl, etc. So with the elimination of a smaller molecules, it takes place from the monomers. From which compound you are going to eliminating as a smaller molecules? From the monomers, and that monomer should be containing polar groups. And that polar groups are you are going to be eliminating as a smaller molecules. And finally, it will lead to the formation of a giant molecule, a higher molecular weight of compound, or a macromolecule is said to be polymer, and this phenomena is called as condensation polymerization. So finally, once again I am repeating, guys, the condensation polymerization can be defined as elimination of a smaller molecules from the monomers which are containing polar groups, and finally it will lead to the formation of a giant molecule, or a macromolecule, or a strong polymer, or a rigid polymer, or a tough polymer is called as condensation polymerization. And this condensation polymerization we can also call as here step growth polymerization. In the last class we have discussed that is addition polymerization, which is also called as chain growth polymerization. And the second thing is here condensation polymerization we can call as a step growth polymerization. Step growth means the step by step mechanism is nothing but in order to understand about the particular polymerization reaction, we should know what is the step-by-step process. So in this condensation polymerization, the step-by-step process is increasing. That's why here condensation polymerization we can explain by the stepwise process. That's why the condensation polymerization we can also call as step growth polymerization. See, it's a reaction between a simple polar groups containing the monomers with the formation of a polymer by the elimination of a smaller molecules like H2O and HCl, etc. Just now we have discussed. And during the polymerization process, if the polymer is formed with the loss of smaller molecules like water or ammonia, etc., then this type of polymerization is called as condensation polymerization. Understood? Next, from third point is, it is also known as step growth polymerization. And here, for this condensation polymerization, which is also called as, what is that? Step growth polymerization. And the best example for this step growth polymerizations are thiacol rubber, nylon 6 polymer, nylon 6,6 polymer, urea formaldehyde resin, bakelite resin, novolac resin. So these are the best example for this condensation polymerizations. And next one. So here, one of the best example for this, that is nylon 6,6 polymer. The best example for this nylon 6,6 polymer. So actually the nylon 6 and nylon 6,6, these two condensed polymers mostly widely used in textile industries. Generally we used to call as nylon cloths. Nylon 6 and nylon 6,6. And also this nylon 6 and nylon 6,6 we can also call as polyamides. Next point is polyamides. So my dear students, so why we are called as this nylon 6 and nylon 6,6 as a polyamides? Poly means, as you know, that is many. And what is mean by amides? Amide is nothing but amide group, that is NHC double bond O group. Okay. In nylon 6 and nylon 6,6 polymers, there will be a many amide groups are present. In nylon 6 polymer, many amide groups are present. Here nylon 6,6 polymer, many amide groups are present. That is the reason the nylon 6 and nylon 6,6, these two polymers we are calling as polyamides because of many amide groups are present in nylon 6 and nylon 6,6 polymers. And this nylon 6 and nylon 6,6, these two polymers we can synthesize or we can prepare by the condensation polymerization. Okay guys, so let's see the best example for this condensation polymerization in our engineering chemistry syllabus as per JNTU or as per our MLRS R24 regulation. Here nylon 6,6 polymer we can prepare or we can synthesize definitely from the monomers. And here for the synthesis of nylon 6,6 polymer we have to use, so here before that one point I want to tell you, that is nylon 6,6. So here what is meant by 6,6? The number 6. So 1 6 is represent the number of, what is that? Number of carbon atoms. What is that? Number of carbon atoms which are present in one monomer, and 1 6 is represented the number of carbon atoms present in one monomer, another 6 is represented that another 6 carbon atoms. Another 6 carbon atoms present in another monomers. That's why, so here nylon 6, comma 6 we can also call as copolymer. Nylon 6, comma 6 we can also call as copolymer because of we are using two different types of monomers. That is the reason nylon 6, comma 6 we can also call as copolymer because of we are using two different types of monomers, and that two different types of monomers which are consisting of 6 carbon atoms are present in one monomer, that is hexamethylene diamine, and another 6 carbon atoms are present in another monomer, and that we can call as adipic acid. So that for the preparation of or for the synthesis of nylon 6, comma 6 we are using two different types of monomers, that is hexamethylene diamine and second one is adipic acid. And these hexamethylene diamine and adipic acids are these two monomers which are undergoes a condensation polymerization, and finally it will leads to the formation of a nylon 6, comma 6, a polyamide, and that we can use it in textile industries. Okay guys, and let's see, so how can we prepare or how can we synthesize this nylon 6, comma 6 polymer, that is a polyamide. So hexamethylene diamine, the structure of hexamethylene diamine is hexa means 6, methylene group is CH2, di here we can call as di, di means 2, amine, amine means 2 amine groups. So hexamethylene diamine is the one monomer which are consisting of here 6 carbon atoms. Another monomer is adipic acid. Adipic acid is nothing but a tetramethylene dicarboxylic acid. Tetra means 4, methylene groups CH2. So tetramethylene dicarboxylic acid, which is also called as adipic acid, and these two monomers which are undergoes a condensation polymerization by the elimination of a water molecules. By the elimination of water molecules, and finally it will lead to the formation of nylon 6, comma 6 which is also called as polyamide. Second example for the condensation polymerization is polyester, and we can also call as steriline. Polyester, generally we used to call as a polyester cloth. But the polyester, and many ester linkages are present in the particular polymer. That's why the polyester polymers mostly used in textile industry for making of polyester cloths, and which is also called as steriline, and which is also called as another name for this dacron. So for this preparation of the polyester, here we can also we use two different types of monomers. One is the ethylene glycol and one is the terephthalic acid. And this methylene glycol and the terephthalic acid which are undergoes condensation polymerization by the elimination of a water molecules, and finally it will lead to the formation of steriline or dacron. So these are the best example for this condensation polymerization with two examples. One is the nylon 6, comma 6 and second one is the polyester. We have the many examples are there. Urea formaldehyde resin, bakelite resin, novolac resin, and nylon 6 is one more polyamide polymer. All these polymers are we can synthesize by using of this condensation polymerization, and which is also called as step growth polymerization. Please make down notes. And the second topic, so types of polymerization, we have discussed the two different types of polymerization. One is the addition polymerization with examples, and second one is the condensation polymerization with example as per our syllabus. And the next topic is plastics. So plastics is nothing but generally in our daily life we are using many plastic materials. But your concept is what is plastic materials? So how it is made up of? Nothing but, so plastic is also one type of higher molecular weight of organic materials, organic compounds that can be molded into any desired shape by applying any temperature, by applying heat, or by applying some pressure. And the plastic materials is nothing but, it is also one type of higher molecular weight of compound We can model, we can give the any shape by applying the pressure and heat and pressure in the presence of catalyst. And such type of higher molecular weight of substances, higher molecular weight of organic materials, we can call as plastic material. You please be understand, the plastic materials is nothing but it is also one type of polymer. Nothing but it is also higher molecular weight of compound, higher molecular weight of organic substance, that we can give the any shape, that we can give any desired shape by application of heat and pressure and in the presence of catalyst. So we can give the any shape to the bulk one higher molecular weight of substance is called as plastic materials. So originally, so plastics are discovered and then developed based on the trial and error methods. Second point, the present type is sometimes referred as a plastic age because of the uses of polymeric materials speculated in the large variety of applications. And third point, this rapid growth has taken place only in the last 50 years. So it was man's desire to develop plastics for engineering applications of replace glass and the metal and ceramic materials and wood and other materials for the construction fields. So these are some of the important points for the regarding for these plastics. So next one, the classification, that's based on the structure, based on the type of the resin materials we are used in the manufacturing of plastics. These plastic materials are we can classify into two types. One is the thermoplastic resin materials and second one is the thermosetting resin materials. And these two types of plastic materials or they are classified. These two types of plastic material, they are classified based on the structure and as well as the based on the type of the resin materials which were used in the industrial side which were used in the manufacturing of plastic industries. So based on the structure, based on the type of resin materials, these plastic materials are we can classify into two types. One is the thermoplastic resins and second one is the thermosetting resins. See now, thermoplastic, thermosetting. So first one is, let's discuss thermoplastic resins. Thermoplastic resins, the first point is thermoplastic resins we can synthesize or we can prepare, that is addition polymerization. In the previous class, we have already discussed about the addition polymerization. So which type of monomers are involved in addition polymerization? That is unsaturated chemical compounds. Unsaturated chemical compounds are nothing but the monomers which are containing unsaturated groups, like I said, double bonded group or triple bonded group or alternative double bonded groups. Double bonded compounds, triple bonded compounds or alternative double bonded compounds are we can call as unsaturated chemical compounds. And these are the unsaturated chemical compounds are participated or involved in addition polymerization. In the similar manner, for the preparation of these thermoplastic resins, for the manufacturing of these thermoplastic resin materials, so we can use these unsaturated chemical compounds. That's why, so these thermoplastic resins are we can prepared by addition polymerization process. That's why, so these are the thermoplastic resins these are the very straight chain or slightly branched polymers and various chains are held together by weak van der Waals forces. Nothing but thermoplastic materials, thermoplastic polymeric materials, they are held together by the weak van der Waals forces. Because the thermoplastic resins are we can prepare or we can synthesize by the unsaturated chemical compounds, and these are the unsaturated chemical compounds are held together by the weak van der Waals forces. Second point, and these thermoplastic resins are very soft. Nothing but these thermoplastic resins are we can define which can be softened on heating and hardened on cooling. అంటే thermoplastic resins which having some important properties that we can soften or heating. అంటే we can by heating of the particular plastic materials that is going to be very soft. And after that, while cooling of the particular plastic material, so what will happening? That particular plastic material is going to be hard. That's why thermoplastic resins can be defined as these are the resin materials which can be softened on heating and hardened on cooling. That's why, so such type of plastic materials generally we say to be thermoplastic resin materials. Generally, these thermoplastic resins are soluble in organic solvents. Generally, we have discussed three major important properties of this particular thermoplastic resins. One is thermoplastic resins are we can derive by using of addition polymerization. Second point, the thermoplastic resins are we can prepared by the unsaturated chemical compounds, and these unsaturated chemical compounds are held together by the weak van der Waals forces. That is the reason, due to the presence of weak van der Waals forces present in between the unsaturated chemical compounds or in between the monomers, these thermoplastic resins are which can be softened on heating and hardened on cooling. And most of this third important property is these thermoplastic resins are easily soluble in organic solvents like benzene or toluene or etc. All these organic solvents, these are the thermoplastic resins are easily soluble in organic solvents. The best example for is polyethylene. See na, polyethylene, polyvinyl chloride, polystyrene, methyl acrylates. All these are the best example for this thermoplastic resins. One more important point you should remember that whatever the polymers we are prepared, we are synthesized in addition polymerization. All that polymers are the best example for this thermoplastic resins. Because of all these polymers are we can prepare by this addition polymerization. That is the reason. So whatever the examples we have discussed in addition polymerization, the same examples applicable for this thermoplastic resins. Yes. A second type of category is thermosetting resins. Thermosetting resins or thermosetting plastic materials are we can prepared by the condensation polymerization, and which is also called as step growth polymerization. That is the first point. Thermosetting plastics are prepared by condensation polymerization. Here, second point, so various polymeric chains are held together by a strong covalent bonds. This is the most important point, please. First point is thermosetting resins. Thermosetting plastics are very strong, very hard, and very tough polymers. And these thermosetting polymers are we can prepare by the condensation polymerization, which is also called as step growth polymerization. Just now we have discussed about this condensation polymerization with examples. For example, nylon 6, polyester, or which is also called as dacron, and which is also called as stearinylene, and urea formaldehyde resin, bakelite resin, novolac resins. Yes, many examples are there for this thermosetting resins, because of which are prepared by the condensation polymerizations. And these are the thermosetting plastics are the monomers. For example, let's see the best example for this nylon 6,6. Just now we have discussed. In the nylon 6,6 polyamide polymer, we use two different types of monomers. One is the hexamethylene diamine, and second one is the adipic acid. And these two monomers are held together by a strong covalent bonds. That is the reason. So various polymeric chains are held together by the strong covalent bond. Due to this reason, a strong covalent bonds, the thermosetting resins are very hard. very strong. That's why, so thermosetting plastics are get hardened on heating. Thermosetting reagents are during heating, during by applying the heating or by applying the temperature. So what will happening? These type of thermosetting reagents are get hard, and but they cannot be softened on further. What is that? By heating. That is, thermosetting plastics get hardened on heating. During heating process, what will happening? These are the materials are going to be very hard, and once hardened, they cannot be softened again. They cannot be softened again. We cannot convert into soft again. That's why, so these thermosetting plastics are very strong, very hard, and very tough polymers. And best example for the thermosetting plastics are butylide resin, polyester resin, nylon 6, nylon 6,6, urea formaldehyde resin, novolac resin. These are the materials. These are the nylon 6,6 polyamides, urea formaldehyde resin, and novolac resins. These are the best example for this thermosetting resins. So the compulsory question, Anna. So there will be asked, write the differences in between the thermoplastic resin and thermosetting resins. So these are the best example for this pictures of thermosetting plastics: AC motor, die cuts, and electronics, soldering materials, and PCB. Next one, FPC fixed and high temperature and transformers. These are the many electrical goods we can use these thermoplastic thermosetting resins. See now, the major differences in between the thermoplastic resins and thermosetting resins are thermoplastics and thermosetting plastic. First point, what we have discussed, the first point, thermoplastics are usually formed by the addition polymerization. Yes, is it right? Second one, thermosetting plastics are often formed by the condensation polymerization. One point, first point, please be carefully. Thermoplastic resins are we can prepare by the addition polymerization. Second point is thermosetting plastics are we can prepare by the condensation polymerization. Second point for these thermoplastics, the thermoplastics it containing a long chain linear polymers, a straight chain linear polymers which are held together by the weak van der Waals forces. Thermoplastic resins consisting of a long chain linear polymeric chains which are held together by the weak van der Waals forces. But whereas in the case of thermosetting plastics, it contains 3D network structures, three-dimensional network structures, a cross-linked network structures, and which are held together by a strong covalent bond. So due to this weak van der Waals forces present in the thermoplastics, usually these thermoplastic resins are usually become softened on heating and hardened on cooling. That is stiffened, stiff, very rigid on cooling. That is the reason. So due to this reason, the thermoplastic resins are we can define as those plastic materials which can be softened on heating and hardened on cooling. We can call as thermoplastic resins. And it comes to these thermosetting plastics, it does not become soft on heating until during the heating process, and when you're applying the temperature or when you're applying the heat. So what will happen? This type of plastic materials very get hard, and we cannot convert into softs by heating. That's why, so thermosetting plastics are very hard, very rigid, very strong polymers. Thermoplastic resins are very expensive and thermosetting plastics are very cheap. Next point, thermoplastics are soluble in organic solvents. One of the most important point, thermoplastic resins are, what happened? Thermoplastic resins are soluble in organic solvents, whereas in the case of thermosetting plastics they are insoluble in organic solvents. Second point, next point is they are usually very soft, very weak, and very less brittle in nature. One of the most important point, thermoplastic resins are very soft, very weak and less brittle in nature because of due to the presence of a weak van der Waals forces in thermoplastic resins. These thermoplastic resins are very soft, very weak and less brittle in nature, easily break because of the bonds which are presented in the bonds which are presented in between the two polymeric chains are very weak. So when we are exposed to the heat or when we are exposed to the temperature, so what will happen here? So that weak van der Waals forces are there easily breaks and finally it facilitates the easy movement of the polymeric chains. That's why thermoplastic resins are very soft and very weak and less brittle in nature. But whereas in the case of condensation, whereas in the case of thermosetting resins, they are very hard and very strong and more brittle in nature because of in thermosetting resins are formed by condensation polymerization. And when we observe the polymeric structure, and many polymeric chains are held together by a strong covalent bonds. The bonds which are present in the many polymeric chains, they are held together by a strong covalent bonds. The covalent bond is very strong. We can't easily break when we are exposed to the temperature. That's why thermosetting resins are very strong and very hot and more brittle in nature. These are the most important point by the thermoplastic and thermosetting resins. Thermoplastic resins can be remoldable. Thermoplastic resins we can be remolded and we can give the any shape. We can remolding process. And thermosetting resins we cannot be remolded because of thermosetting property is, so once these thermoplastic resins get be hard when we apply the temperature, but we cannot be to salts. That's the reason. So here we cannot be remolded into desired shape, but whereas in the case of thermoplastics, we can give the any shape. We can easily remold it into any shapes now. And last point is, an example of thermoplastic is polyethylene. An example for the thermosetting is bakelite resin. Many examples are there. Polyethylene, polyvinyl chloride, polyvinyl cyanide, polybutadiene. Because of all these polymers which are having, we can call as unsaturated chemical compound. Because of unsaturated chemical compounds we can prepare by this. What is that? Addition, polymerization. They are involved in the addition, polymerization. Here also thermoplastic resins are also we can prepare by the addition, polymerization. That is the reason the same example for the addition polymerization is similar to this thermoplastic resins. And one of the example we have discussed in the condensation polymerization, for example, Novolac resin and bakelite resin, urea formaldehyde resin, nylon 6 polyamide and nylon 6,6 polyamide. These are the familiar example for this. What is that? Thermosetting plastic materials. Okay, thank you guys. And in next class, we will discuss preparation and the properties and applications of the PVC, polyvinyl chloride, polyvinyl cyanide, Novolac resin and bakelite resin, nylon 6 and nylon 6,6, Teflon. Yes, these are the topics we will explain in the next class. Thank you very much.